So in today's video, we're going to take a look at how we can determine the equation of the tangent line at a given point. And so if we're looking at slope-intercept form, then the equation of the tangent line can be described as y equals dy dx times x plus b. And of course, there are many different forms of linear functions. This one is just my preferred form. And so we know that the slope of the tangent line is obviously going to be the derivative evaluated at our given point. And so I'm going to actually do a particular example in which we illustrate the process of how to actually determine the equation of the tangent line at a particular point. And so here we have f of x equals to 3x cubed plus 2x plus 1, and I've actually drawn a bit of a sketch down here in orange. And we want to determine the equation of the tangent at x equals 1. And so it would actually be very helpful to determine the value of the function at x equals 1. And so if we were to input f of 1, then we would in fact get 6, and you can go ahead and try that out for yourself. And so we know that on the graph of the function, we're going to have the point 1 comma 6, as I've kind of tried to approximate over here. And so what we're going to go ahead and do is, first of all, it would be very helpful to actually take the derivative in order to determine the slope of this tangent line, and then we'll try to fill out the missing pieces of information after that. And so if we were to actually take f prime of x, we would just need the power rule over here. And the derivative of 3x cubed, we know by the power rule, is just going to be 9x squared, because we can bring that 3 down and kind of multiply it by the coefficient. And then we know that the derivative of plus 2x is just going to be positive 2. And the derivative of plus 1 is just going to be 0 because it's a constant. And so this just directly comes from the power rule. And so what we can do now is we can actually determine the slope of the tangent line at x equals 1, because this right over here, f prime of x, kind of just tells us the equation of the slope of the tangent line. And so if we want to determine the slope at our given point, then we just need to input f prime of 1, right? Because we know that the slope is actually varying depending on which x value we input. And so here we'll get 9 times 1 squared plus 2, which is just 9 plus 2, which is equal to 11. And so 11 is going to be the slope of our tangent line at x equals 1. And so now we know that the equation of the tangent line is going to have the form y equals 11x plus b, of course, in slope-intercept form. And now let's actually see what we can do to evaluate or to actually determine this y-intercept over here. And so we know that the tangent line has to kind of intersect the graph at this particular point. It has to kind of scrape the graph at x equals 1. And so if we were to kind of approximate it, it may look something like this, right? It kind of just scrapes the graph at this point, it intersects it at x equals 1, or at the point 1 comma 6, and then it kind of just like leaves the graph alone after that. And so of course this is just an approximation, it's not very accurate. But with that in mind, we know that the tangent line actually has to pass through the point 1 comma 6. So we know it's going to contain the point 1 comma 6. And so with that in mind, we can actually go ahead and input this point into the general form over here and actually solve for b. So let's actually do that. So here we'll get 6 equals 11 times 1 plus b. And if we're going to solve for b, we can go ahead and subtract 11 from both sides, and we'll get b equals negative 5. And so that's our y-intercept right over there. And so we know that the general equation of the tangent line is going to be y equals 11x minus 5. And so, of course, the tangent line is going to vary depending on which input value you're looking at. But for this particular value, for x equals 1, the equation of our tangent line is described right over here. And we're essentially done. So that's how you can actually use the derivative in order to determine the equation of the tangent line at a particular point. Next time, we're actually going to take a look at the equation of normal lines, which is a little bit more intense than the plane tangent line, but it is still quite simple.